المحاضرة عنوانها طبعا وسائل مكافحة باعتماد المواد العضوية يعني للعلم بس. Sir Ralf, stage for you.
Dear beekeepers, thank you very much for your warm welcome here in Erbil. I really like the city. I like the people here. They're all very friendly. And I want to present you with very nice greetings from Switzerland, from the Swiss beekeepers, with a typical Swiss Grüezi miteinander. I am talking about treatment concept.
Try to speak slowly so they can understand it. Okay? Speak slowly, they can understand.
Okay. I am presenting a treatment concept which is working year-round and which is using only organic substances. Andermatt BioVet is a group, and this group has been established 30 years ago and is in the field of crop protection, but also bee preservation. We want to offer our clients, our customers, products where they can produce food that is without any chemical residues. Therefore, we use all our know-how and organic active substances to create safe, easy to use, and affordable solutions. The consumer, and also the bees here, they tell us that they want to have pure water, they want to have pure food, and we have now the technical means to detect also very, very small amounts of residues of chemicals, be it pesticides or be it Varroa synthetic. Also, we have to fight with honey fraud. You have seen the number of tons produced of honey in China. I doubt that the bees are so much more productive in China than in other parts of the country, of the world. So the beekeepers, they need to be prepared to answer to critical questions of their consumers. We're working in an integral, holistic approach where we have the climate and the life cycle of the bee. This is very local, and you have to adapt the use of the products to these local conditions, climate and your bee. We also have the life cycle of the Varroa mite. This is a bit more international. So the life cycle of the Varroa mite is very simple. We have different active substances available for the treatment. Here we're talking of 3 substances: formic acid, oxalic acid, and thymol. And all these things together, we fit in a treatment concept that covers your needs year-round. Synthetic acaricides, they work very targeted. They go to one specific channel of the Varroa mite and block this channel and kill it. They are very efficient at low concentration, but residues staying in the hive at low concentration lead to resistances. The mite will, after a few years, no longer react on this substance. With the organic acaricides that we're talking, these target specific organs of the mite, or they target the organism of the mite as a whole. They're highly efficient if they're used correctly, and the bees and the mites, they have lived with these substances for thousands of years, already in small doses. You will find thymol in every honey, You will find formic acid everywhere. Also in the bee venom, you will find oxalic acid in different plants and also in the honey. So a resistance due to low residues to these three substances is not possible. Now, is it possible to work with organic solutions compared with the technical approach of the synthetic acaricides? I'm comparing here the US beekeepers and the Swiss beekeepers. The Swiss beekeepers, they work for several years now. 98% of them treat with organic substances only. They don't use antibiotics. The Americans, they use synthetic acaricides because they're fast, they're cheap. And they use, as a standard in winter food, antibiotics. If you ask them why, they don't know. It's just better than not. What we see now as a result is the Americans report 30 to 40% of colony losses every year. This is money that's getting lost to the beekeeper. Colonies that die do not produce honey. And the harvest of honey that they get is 20 to 25 kilo in average for the surviving colonies. In Switzerland, we have two groups of losses. One is winter loss. This is during the cold period where the bees die, do not survive, and I will explain you later on a little bit. And we have colony loss in summer, which can be due to robbery, which can be due to swarms going off, colonies just dying off due to accident, flooding, fire, and so on. And still, with this approach, we harvest the same amount of honey. So it is working. It is also commercially working. So what do we know about the Varroa? We know that the Varroa, when we start at a very low infestation, will double in number every 3 weeks. Every 3 weeks, you will have double the number of Varroa in your hive. In spring, summer, we have a big increase because the temperatures are good. Food is available for the mite. And food is brood, bee brood. The green line is drone brood, which the mites love. And the red line is the number of brood cells of worker brood. Now, keep in mind, every bee that has been parasited by a Varroa mite is useless to the colony. So if we have the brood here in spring and we have Varroa, it's not a big problem. But when we go on and the brood cycle reduces, the bees, the queen stops laying eggs, we have less brood. Then we have almost for every cell one Varroa mite. So all the bees that are born in that time here, when we don't do anything, they're useless for the colony. And this is exactly the bees that we need for the colony to survive winter. So we can have an alarm level and we count. Maybe you cannot see it because it's very low in the picture. In summer, we look at the natural mite drop, and when we see there is more than 100 Varroa mites falling every day, you absolutely have to treat. Do not wait. In fall, it goes down to 10 mites per day. And in winter, it goes down to 1 mite If one mite falls, you have to treat. So the generation cycle of the bee is more or less 1 year. The Varroa mite has a generation cycle of 3 weeks. So it's much faster in reproducing, and it's also much faster in adapting to any stressor. So if you have a stressor like a synthetic acaricide, and you have residues, 15 generations of bees have time to adapt to this stressor. And this is why after 3 to 4 years, most of the synthetic acaricides do not work anymore. We have several ways of counting Varroa mite or determining the infestation. One is just counting the natural mite drop. Another one is using sugar to dust the worker bees and count the fallen off mites. You can do the same with CO2 and with dishwasher liquid or something like that. And with that, you get a percentage of mites per bee. This percentage is very important. But newly, we have also the possibility of using technologies, picture processing. This is a group, a Swedish group, working with pictures. So you pull a frame, you take with your mobile phone, you take 4 pictures, you mail it to the computer, and the computer will tell you your colony has this and this infestation. It will also tell you if you have a queen. And this system is learning perpetually. It's not yet a mobile application because this picture processing needs a lot of power. You have to send in. So, now why do we need to know the Varroa infestation? In Germany, we had a big research being done over several years. Now it's maybe 15 years. It's the third period of 5 years. And they found a clear relation, not between viruses and colony losses over winter, but between Varroa mite infestation and colony loss. On the bottom line, you see the percentage of Varroa mites per bee. And here you see the probability with which the colony will die. So if you have 7% infestation, you have 8 to 10% of the colonies dying. And this is statistics. You cannot change it. It will be the case. If you're at 20%, you already lose 40 to 50% of your colonies. And this is dramatic. So this is why you need to know where you stand and how you want to save your colonies. Now this is big. We have the 3 substances that I talked to you, which I choose, or which we choose for Switzerland and Germany as the main ingredients of our concept because they're highly efficient. Formic acid is highly efficient if you're at low temperatures. It also penetrates the capped brood cell. So once the Varroa mite is in the brood cell, formic acid is able to penetrate the cap and go inside the brood cell and kill the mite. Oxalic acid cannot do this. Oxalic acid works only on contact with the mite. Oxalic acid has to be in contact with the mite. Thymol is a little bit slower before it starts. You have a very low risk for the brood. and you have a high efficiency. But thymol also does not work inside the brood, so you have to use it for a prolonged time, several weeks, so that all the brood and all the Varroa from the brood may exit and get exposed to the thymol. There is some work being done on hop extracts, and also newly on lithium salts and some other essential oils, but they're not very promising at the time being. For the lithium salt, I think this will be a possibility in future, but this will take at least 10 years. On this curve, we see the speed of action. If you apply formic acid, you have an immediate reaction, very high drop of mites right away in the first day. With oxalic acid in 2 different ways of application, this is a bit slower, and with thymol you have like a retard action. In the end of the year, or in the end of the treatment, the efficacy of these products is comparable. It's more or less the same. So what does it look like now with the bees? If you don't do anything, the Varroa will develop according to this red line, double every 3 weeks. And when it gets colder, this development will decrease. So what we recommend is do a first treatment in spring before the honey flow starts. And that you can do by cutting drone brood. The mites love drone brood, so you can cut out the drone broods and remove many mites. This is a mechanical treatment. But you can also use oxalic acid and spray it on the bees. All the mites that are sitting on the bees will die, and you will have 30% reduction of your mites, because the other 70%, they're sitting inside the brood cells, so you won't get them. But this first treatment makes you start clean in a new season. You will want to do a first summer treatment after honey harvest, where you can use formic acid, oxalic acid, or thymol. This comes in Switzerland at the end of July, beginning of August. Here. And we usually do a second summer treatment, depending on the product, in September. So why does the infestation grow back here? What can it be? Strong colonies go and rob weak colonies. And they do not only rob the honey, but they also take Varroa back home. So you can treat your colonies perfectly. They can be perfectly clean after your treatment, but your bees, they will go shopping, and they will bring back new Varroa. And this is why we recommend a winter treatment when there is no brood with oxalic acid. You want to take a picture? So for the last 2 or 3 years, researchers have also looked after different methods. They want to create a bee that is defending itself against Varroa. They want to make it easier for the beekeeper. They want to use less of the treatments. Now again, we start with this curve for the Varroa development. But this time, after the honey harvest, we take out all the brood. And with all the brood, we take out all the Varroa that is inside the brood. We destroy this brood. This sounds cruel, but it's very effective because the Varroa inside the brood cells have already damaged the brood. So these bees coming from this brood, they are worthless to the colony. And we found that the queen will start laying eggs at high speed, and the colony will not suffer from this treatment. If we don't do anything in December, again, we may start with a higher infestation. This is why we recommend still a winter treatment with oxalic acid. What are the products that we have? Formic acid in liquid, formic acid in gel. We have dispensers. If you use formic acid in liquid form, you need the right way to dispense it evenly. The limitations that we have with formic acid is the temperature. When you have higher temperatures with formic acid, you have to apply the product in the early morning hours. The evaporation is not so strong, and the bees leave the hive anyways. If you are at lower temperatures, you preferably want to apply it during the day when it's not so cold, and you use a different concentration. With oxalic acid, we have a big variety of products. Oxuvar in two forms, Apibioxal from Italy, Ecoxal from Spain, Varromed Oxybi from Austria and Germany. With Oxuvar and also Varroxal, which is the powder, a liquid and a powder, you don't have a lot of limitations. The only limitation that you have is that no brood is allowed. So if you still have brood, you have to do repetitions. It's safe also at very high temperatures. There's no temperature limitation. And also in winter, you can even apply it when it's freezing outside. This is a very good approach. With thymol, we have Apigard, Apilife and Thymovar. You can tell which one I prefer. The dosage, if you have high temperatures, also apply it in the early morning and use only half of the recommended dose. With regular temperatures like today, you can apply during the day at the full dosage. And you have to place the strips close to the brood area. And this is important because directly over the brood area, you have a constant temperature of the brood. And that gives you a good evaporation rate, a constant evaporation. And you should not use it at low temperature because you have no brood then, and you don't have any evaporation. The strips are unbreakable. They're well tolerated by the bees, and they protect from reinfestation. So all the Varroa that are brought back from your shopping bees, they will be killed in this long-term treatment with thymol. This is results of the work done by Uzanov. Alexander, he did his PhD on this, the use of thymol at high temperatures. We can see here the temperatures, they went up to 40 degrees. And the average temperature was close to 30 degrees. And he found out that if you don't do anything, you will have the doubling of your Varroa mites during the season, all 3 weeks. So this gives you this expected infestation. And he did the treatment with Thymovar, and this is actually what he measured, the green line. So he stayed at an infestation level of 1 to 2%. This is per 10 grams bees. You can say 1 gram of bees is approximately 10 bees. What happens? How does the colony react? The colony will move down, away from the cells, and the bees will also try to reduce the evaporation. They can do by using propolis around the strips or by trying to remove it, and they can only remove the part that does no longer contain any thymol. And in this work, there was no queen losses. So that's what Alexander Uzanov found out. Control of the infestation is very good. Also, when you have hot temperatures, you don't have any negative consequences on the colonies. The treatment was applied as directed after the honey harvest. And he worked now with temperatures up to 40 degrees. He worked only with 25% less in concentration. So, a conclusion. What does the beekeeper need to know? The beekeeper has to know the brood cycles of his bees. He has to know when the bees are without brood. The beekeeper has to know the Varroa infestation, because that tells him when to act. And the beekeeper should use different substances. Even though we have no risk of resistance, he needs to switch substances, use different substances during the year. I thank you very much for your attention.
Thank you. Thank you very much, Mr. Ralf, for this interesting, really interesting and very clear presentation. I congratulate you for this success.
Thank you.
So I will open the stage for you, please. First question.
The queen will reduce laying eggs or stop laying eggs. So when it reduces laying the eggs, it may also that the formic acid vapors kill also the very young brood. And you see only that there is no eggs. But it may be that the queen lays, but the workers eat the eggs.
يعمل بثلاث اتجاهات. يؤثر على تخفيض وضع البيض من قبل الملكة. ممكن أن يؤثر على الحضنة، وبالتالي إذا وضعت الملكة البيض ممكن أنه أيضا تؤكل من قبل الشغالات. فتأثير ثلاثي.